So one day, there was a little hobbit that was actually being very happy, joyful in life. And along came a wise old man presenting a quest, presenting something that is not that joyful, not that pleasant, but it had to be done. And even though his first reaction for the people that are sitting in the back, you can see is, are you crazy? You need me to take this thing all the way across the country, all the way into the darkest hells of Mordor. This is how a lot of people we've worked with in the past think about refactoring. Are you crazy? This will take us 3 months and we need to write a business case for this. We don't get any possibility to do this. And this is what we want to challenge in this session. More or less. Now, who are we?
Who are you?
Who am I?
You're a mad genius.
I'm a mad genius.
Yes.
Mostly on the mad part. We'll see about the genius part.
I'm just a software developer. No, I'm more than a software developer. I'm a software craftsmanship apprentice at Codurance, and I'm learning to be a software craftsman.
Right. And you're Franzi.
And I'm Franzi, yeah, as the slide says.
Yeah, as the concept of these names. I'm Erik. I'm the mystery guest of this conference. I'm the one person that is not in the booklet. We did that on purpose, so that's okay. I'm the founder of the software craftsmanship community in Belgium. And as Chris already mentioned, we are running the Socrates Belgium in October, for which you will be handed out flyers during the rest of the afternoon by one of the co-organizers, Koen. But enough about us. Now, what is refactoring? What does it mean? What is refactoring? Moving code about. That's interesting. What else?
Without affecting what it does.
Without affecting what it does. What do you mean?
So restructuring stuff to have a better structure without modifying the external behavior.
So restructuring to have a better internal structure without changing the external behavior. Thank you.
So we change the structure. How can we be sure that we don't change the behavior? All right.
Tests.
You already know about this. So I'm going to take the example that the explanation that Rachel gave. What we typically see when we try to do refactoring is we move things around. We split up a big pile of a lot of code into smaller, more usable, is Alex here? More usable little bits of code. And basically, using the Lego metaphor here, but why not? We all most of us played with Lego before. So trying to change the structure for it to become more maintainable, more usable, while not changing the behavior. This is basically what refactoring is about. Now, if we start to try and recognize, to try and figure out what a code base is doing, what would be the best starting point?
Any ideas?
Did we warn you about the fact that it's going to be a slightly interactive session? Maybe we should have done that before. So let's start again. I'm Erik, this is Franzi. This is going to be an interactive session. We're going to ask you questions just to make sure you don't fall asleep just after lunch, having the sugar dip in about 20 minutes or so. So how can we discover something? What would be a good first step?
What do you do when you first start to look at the code that you want to refactor?
Read the documentation.
Documentation. Unfortunately, we lost that in the fires of Mordor.
Yes, that was already taken down by the Nazgul.
Make sure it's tested first. So that's a very important thing.
Yeah.
But even before that,
How?
let's say we don't have any tests yet. Understand what it does. Yeah. That's a very good thing. Like how much can we understand? Like let's take this code. Yeah, so it's don't be afraid. You don't have to understand it.
No.
But basically what it does is the product owner said this was some kind of game they implemented and they needed to make a change in this method. And yeah, the previous developers are not here anymore. So, and neither are the business people that knew about the features. So we don't really know. They're also very busy, the business people. So,
Have I mentioned the Nazgul? It's too late.
So one thing that we can do is just, execute it. See what it prints. So for this code, we already had some kind of main method. So we just ran it, and it prints some stuff on the console. So let's see. It says something about questions. Here seems to be rock questions, pop questions, players with coins and rolls.
Gold coins.
Gold coins. Yeah.
Now, this is just one big surprise for me, having run about 40, 50 legacy code retreats, is the small amount of people that when you ask them, you have 5 minutes, try to figure out as much as you can about the behavior of this system, that 1 out of 100 would actually run the code. They want to start making changes. But if you don't know what your behavior is supposed to be, how can you make sure that you don't change it? And yes, writing automated tests, awesome. It's not that easy to get started. Why not just run the damn thing? If it is actually a console application, start it, try it, see what it does, get a feeling for it.
Maybe it's a website, so I can click a bit on the website and figure out what it does.
rf/damn.
So you typically, what you want to do, you want to investigate it, and if at all possible, you want to document it. Yes, of course. Thank you for that. But first, we need to discover a little bit about its external behavior. So this is basically, are there any testers in the audience? Or people that believe they have the tester mindset, at least to some extent, not necessarily the role?
Yay.
These are the real mad geniuses. I've had the pleasure of working with these, even in pair programming sessions. These are the people that come up with things that no normal human being would come up with that. And it's called exploratory testing. But we can do that as well, but just maybe on a more basic level, just explore the application.
And we're not talking about automated exploratory testing. We're going to get to that later. It's about manually testing the stuff. So that should be the first thing. If you're not sure how to start, you can start with that. So what next? Let's say we figured out this is a trivia game. You can add players to it, and then they can make a roll, and then they can answer questions, and if they answer correctly, they get gold coins.
So what would be a next step? We want to start changing things in the code base, and we want to start documenting what we discovered, what we've learned. Already here you're coming, write automated tests. I know, we're not there yet. Because typically you need to change something that has a risk in order to inject automated tests. If you're working with an IDE, or if you're more, if you want to do it more risky, you can use an editor as well. But what you could do is start thinking about, if we scroll through the code, what we typically see are things that are not really what they're supposed to be. They might tell you that they do this part. Like this is a very good example. This method is called roll. Now, if we look at it more closely, you don't have to, don't worry. It's probably the only thing within this system that it doesn't do, because it accepts a roll. So the only thing it doesn't do is rolling things, whatever it is. And this is what you see in a lot of situations, where it's just not really what is documented to do. So the biggest problem you have like a person, a very smart person, looking at the code, probably thinking, can we find the previous developer that actually wrote this? Your daily what the fuck rate goes up. And at some point, you kind of see the light. You unlock the mystery of what this thing is supposed to do. And then you go home. Because you don't have time to write tests anymore, so you just go home. So the next day, you're on holiday or whatever, you can try it again. So in Agile, we talk about feedback loops, shortening the feedback loops. So if we discovered that this role method is not really doing something involving roles, why not rename it? What is the risk? It's a rhetorical question. What is the risk of breaking something? So this is also one of the 4 elements of simple design, is about maximizing clarity. This is also about revealing intent of the code. And I prefer to have a method called, it does a lot of things apart from rolling, than a roll method. So naming is never, it's a perfection game. Every single day you get a little bit better at it. But revealing intent again, when we run workshops like this, people are extremely frustrated because they only can rename things. So annoying. Yes, create focus. For the people that were in the lean sessions.
People that were in the lean sessions?
For people that were in the lean sessions, echo. Limiting your work in progress. Just focus on renaming things, which is difficult for people. And then, I'm running out of space. That's cool. You talked about the meaning of life, right?
Yeah. That was more to test the microphone,
but it's in here, of course. I know I should have worn a t-shirt with a drawing on the back instead of on the front. I know.
You can still turn it around when I'm speaking.
I try to. So, revealing intent is also about naming, for instance, magic values. We all know that 42 is the meaning of life, but there are still some poor people out there that don't. So, revealing intent means that it should be extremely easy to read your code. Also to people that don't know how to write code. What if your code was readable by your friend who is doing, I don't know, customer service? If you're in a customer service domain, they should be able to read this. If they can, wouldn't that make life a little bit easier? That you don't have to translate this every single time?
Or even for yourself when you come back, as you said, or for your teammates, because once you figured out what this magic value means, you don't have to give everyone else this work to do as well. So
this will come back a few times. It's again about feedback loops. Use what you have learned, but immediately document it. And not in a Word document on a SharePoint server. Please. Anyone using SharePoint at work? I feel for you. So the best documentation is code. So document this in your code. Make sure that your code reveals the intent of what it actually does. I had like the "I'll be back" quote just to make sure that it's not just about numbers, but I don't have any space left, so sorry.
Just make a new one.
No. I came prepared. I only have a few prepared. So. Now, these things are pretty safe to do, typically. Again, when you're working in Java, C#, in an IDE, it will help you. Risk of breaking things is minimal. Not zero. It's minimal. Now, what if we want to start doing more funky stuff? We need a safety net.
You know, maybe I should show them an example first of how we could reveal intent.
Sure.
So here we can see the previous code where there were 3 int arrays two interarrays and one Boolean array that saved some kind of value we needed for executing our moves, our rolls. And as you can see, those are not really names where you would immediately know what they're about. And also this number 6, I don't know what it is for. But looking closer at the code and how these values are used, I figure out that the processing is actually in the number of gold coins the players have. Because it is increased whenever a correct answer is given. And the 6 is actually the maximum number of players. So that's what we put here. And maybe we already have a question for the product owner if this is supposed to stay the same, if 6 is really the upper bound.
This is an assumption. We cannot be sure about this. But hopefully there are other people who are slightly more sure about this. If you also don't have a product owner, or anyone in business, or anyone using this system, don't refactor it. Because you have no one to, maybe you don't have anyone using this system. That's, you can build in metrics for that. But if you have no clue, if you're only running on assumptions, don't run. Go ask these questions. Now, since we were talking about documentation, does anyone know the concept of a golden master? Yeah.
4 people?
No. You're not allowed to speak. You're up next. So.
4 people.
4 people. All right,
yeah.
Cool. So, what is it about? Where does it come from? Back medieval times, you had blacksmith, weaponsmiths. You would have a master with several apprentices. Something similar to software craftsmanship, but completely different, of course. What would happen is your master weaponsmith would make a sword, for instance, for the king or the queen. And every single apprentice who would make swords would have this golden master to actually compare to. A very basic system, If the weight is the same, if the balance is the same, if the outlining is the same, if it's similar enough, we're good to go. This is a good sword, next. Because a master smith, if he has to go into the details of all of these things just to make sure, is this exactly the same? It would probably take more time than if he would just do it himself. And we can use this concept in our code as well.
That's fine, sorry.
Go ahead, yeah.
Good. What we can do with this thing is, it writes to the console, right? So what we have to do is write an output instead to a file, so that we can pair it with our golden master, our sword that was made when the code was unchanged. And we can compare the output that we had at the start of our refactoring with the output we get when we start to refactor it. And for that to work, I would run this game 500 times. I've already have a main method that runs the game, so I'm just going to use it in my test and do something similar. And then I'm going to assert that the current test run has the same output as the master test run. And the 500 times is just to make sure that there's enough runs of the game that some sort of different inputs and outputs are generated. And how do we actually make it write to a file instead of the console? In Java, you can simply override the system out. So that instead of writing to the standard console, it writes to our file. And then again, I can also just read the file into a string, and I know what the output was. And to run the game, I run it 500 times, and I give it a random with a hard-coded seed. So the first game run is with a seed of 1 for random, the second is with a seed of 2. No, actually the first is with a seed of 0, the second is with a seed of 1. And it runs it 500 times, and it creates a nice output of a really, really long file, and can even do some code coverage and see what my golden master touches. And don't get me wrong, this can be very dangerous thing, because code coverage doesn't tell you much, right? But it gives you some sort of safety net. It gives you some sort of confidence. I mean, if you look at the sword the apprentice made, it can still be brittle. You don't know that. You haven't tried it.
No.
But if it looks fine, at least you get that. So it sells better. If I change something in my code and run the golden master and I break something, I can compare the files. The test will fail, and I compare the files. And I can see the differences in the files. And it will show me much clearer what's actually wrong. Here I just changed the category sports into Sportsy. And that's why the test failed.
2 questions. Why 500? Is that enough? What do you think?
Yeah, sure.
Samir.
As many as you can without slowing yourself down.
Yeah.
As many as you can without slowing yourself down.
So basically, just enough and nothing more. Again,
yeah.
This is a gut feeling. But
randomness in that game?
there was. We solved that with the seed.
Well, the thing is, this execute move method, it takes a dice roll from 1 to 6. So this will be the random part. And it is also random if it's a correct answer or a wrong answer. But since we give the seed into the method, it will always create the same output. It will still be random, but it will be reproducible. And that's what we need to compare the different runs. I think an important part of what Samir said is that we want to run this again and again and again after each refactoring step. So if it takes 2 minutes, that's too long, because we need to run it more frequently. But it also depends on your speed when refactoring, of course. But you should be able to comfortably run it again and again and again. Yes?
If the results are reproducible, how does it make a difference whether you run it once or 500 times?
Because,
That's the same result, right?
yeah, because once I have a winner, the game stops. But then I might not have all the different kinds of situations that can happen in the game if I only do one game. It's the same if you play board game with your friends. Each time you play it, there will be different output.
Do you have 500 golden masters as well?
That's what you have the 500 for, to actually, again, this is one example. So it is perfectly possible within your environment that you need several golden masters, depending on what you're testing. What is your system under test? So this is very simplistic. You just capture the output. It could be that you create a golden master, you have logging in your system. You can capture the logging. There are libraries out there, just to give you a little bit extra information, like the approval tests, which can do this on HTML that's being generated, which supposedly can do this on PDFs. Not in the C# version. But it's the concept of creating a dump of information, typically in a file, because that's easy. And then afterwards, when you change something, when you are refactoring, you have something of a safety net.
I think this also when you have a system and that is regularly in use, you can also capture the input and the output of a typical day, or a typical, you can ask a business person to perform typical tasks, and then you capture the input and the output. And then you compare it again. And if you find a way to automate this, it doesn't have to be perfect code. It's just your safety net for refactoring. So if you can quickly find a way to reproduce the same inputs again and again and capture the output.
So it's essentially a categorization test with one assertion.
Yep.
Yep.
But how come, sorry, if you're generating the constructor dynamically at this time,
Yeah.
the inputs are different from the ones that you generated at the beginning of the game?
Yes. The thing is, the inputs are different, but for each test run, they will be the same inputs, because I control the seed of the randomness. That's the clue. That's the part that is maybe a bit hard to understand, but it's like if you have dice that are actually, if someone has dice that they can cheat with, you know, they're weighted dice, so they will roll the same number again and again and again. This is like that.
Yeah, it's not random. It's a sequence of
Yeah.
numbers.
Exactly.
Semi-randomness.
Semi-randomness.
All right. So
But it's, the concept of the golden master is to take the same input and to try to cover a lot of your code, especially the code that you want to change, and then recreate this in an automated way so that you can compare the output. And this is just an example, but it might be different for your application.
So one thing that is important is a golden master is typically integrated, fully integrated. It can be that it's fully integrated with your file system, your system clock, your database, your external hardware, your USB drivers, whatever. Why? Because your code is written in that way. If your code is written in a way that all these dependencies are somewhere within the spaghetti, we don't want to start and trying to get them out. We first want a safety net to fall back to. And one thing that is important as well, if you have a golden master, because they are not 100% foolproof, test them. Test your golden master. Not automatically. Otherwise, you're going to get into a Big Mac testing thing, an endless loop, and you're going to turn like this. It's not good. What you can do is introduce something that you believe should break your golden master. And I really urge you to practice this one, because the first few times I did this, it can help you figure out the 500 because you changed something and golden master says everything's okay. And you're like, no, it shouldn't be. So you want to verify this as well.
So you can do mutation testing if you've ever heard of it. You start with the code coverage, and once you see that your code is covered, you can do some mutations in the code manually or with a framework and see if the golden master is still green. But let's move on to the next technique.
So what you want to do next, now that you have a golden master, you can start thinking about encapsulating these dependencies because they're annoying. So a good way, you try to find one of these dependencies, try to actually move all of the code. It's again about moving code around, typically, and trying to find a way to actually inject these dependencies. So, for instance,
our printing to the console, it's scattered all over our code, right? Everywhere something is printed out to the console. And what I did is just to test drive a console printer that implements a print method interface, and it will do the printing to the console for me, so that in my tests I can mock this and use something else. So I used TDD to develop this. It's very simple, I know, but in your example it might be something else. And then I changed my code to take a printer object that implements this interface, and everywhere that I execute the system out println, I change it for this method that prints on the printer.
Now, if we have these dependency somewhat pushed out, we can start building isolated system tests. Mostly, again, remember, we set out to learn, to discover more about this code base. This is the storyline, because you don't know what you're going to expect on your trip to Mordor. So you want to learn more and more about it. And then you can use, again, characterization tests, isolated system tests, for who were in the talk by Simon Brown. They are on that level. And this is your assumptions. You can talk about your assumptions, but one of the things that we do a lot, and what Sandro mentioned as well yesterday morning in his talk, was to visualize things. Remember the future-proof versus the straightforward? If you visualize this, it becomes easier to talk about it. So why not, again, use this system tests as your documentation? Write them in a way that your product owner, your business person, or business people actually understand what your assumptions are, and then you can talk about them. Then you can discuss whether or not this is what the system is supposed to do. Because what we see, again, a lot, you start refactoring and you see something that you believe is a bug. That's really cool. You cannot just go in there and fix it. This is the same with testers. A tester would typically say, there's a potential problem in this code, not there's a bug in the code, because a tester typically cannot decide this. When you're refactoring your code, you cannot also just go on your own and decide that this is a bug. What you can do is write a test for it and say, this is what this system actually does, but I thought it was supposed to do this.
I think it's good that we have the printer interface injected into our game, because now I can use my own printer. I used a very simple anonymous class here, but you can use lambdas or you can use a mocking library. Just wanted to make sure it's understandable, but instead of printing to the console, I add the output to a variable, a member of the test class, that I initialize with each test run, and I inject it in the game. And then I can create a test. I can even use parameters and try different values and just see how the output looks like. And even if the output is not as readable for business people, you can use it to understand what the system is doing. You can talk to other people about it. You can find bugs. And this is another type of exploratory testing. It's automated. And these tests can run much faster than the Golden Master or your manual exploratory tests, because they don't use the external dependencies. So you can mock your database values, you can mock the web service input, output, everything, and get what's going on.
So important here is, which system tests do you start writing? Well, which part of your code do you want to refactor most? How do you decide that? This was not a rhetorical question. Sorry, again, interaction.
Yeah.
All right, so.
We already heard about this.
Hmm? The least risky ones first. It depends.
I liked the talk previously about how you can see the hotspots in your code. The code is a crime scene. And you can find the places where there's very complicated code that is changed very often. But in this case, we got the instructions to change the roll method.
Yeah.
So that's why we renamed it by now to execute move, because it doesn't roll. But that's what we're testing, and that's what we're trying to cover with tests. This can quickly blow up. I'm sure you've all seen huge test suites where everything is tested at once. And you can see here that when I set up the game with the players, I always have this output. So this is something I actually don't care about in this test, but I still have to include it in my assertion because it's there. Of course, I could also say, okay, I don't care, I just want to know that this is somewhere in there. There are also methods of doing that, but just focus on, if you want to make the tests more readable, you can change them later as well.
So there are a myriad of reasons why you would pick one part. One is indeed the heat map of where most of your changes happen. If you have someone in your business domain that actually knows what they're talking about, you could talk to those people and say, okay, which is your core domain? The rest we don't necessarily care about.
Some of the stuff is going to be covered in Adi's talk later.
Yes.
So let's not, spoil people for that.
We wanted to push most of the questions to his talk anyway. Yeah. But are you covering that, Adi? Not that much. So okay. Adi will cover that in his session. He still has about 15 minutes to prepare that. Don't worry. We're very agile about this. So one more thing and then we continue.
All right. Since he's not going to cover much detail, apart from the hotspot, which is areas that you're changing a lot and there's a lot of people contributing to it. Another thing to consider is there's this thing called the BCG matrix that's used for portfolio analysis. Boston Consulting Group. They look at different products that you have and which ones do you want to change. So using the same logic into code is interesting because sometimes you have this area which is, it looks like it's in need of refactoring, but that part of the code is generating a lot of revenue. The code is messy.
Yeah, so basically going from what provides the most value to the customer. I think it's a good thing.
And
but
I would say the opposite. If it's providing a lot of value, but you don't need to change, so you should not refactor.
I say there's different reasons for refactoring, and if the business person is nervous about the part that brings the most value and isn't sure that it's doing the right thing, then there's definitely a reason there to refactor. But if it's something that has worked for a while and everybody's confident with it, sure, we can leave that risk later.
And it hasn't changed a lot or might not change a lot in the future. Again, think about the future-proof thing.
Yeah.
If it hasn't changed in the last 6 months and there's nothing in your backlog that it has to change in the next 6 months, stay away.
I think we need to move on to
that's a good idea.
schedule.
So,
but Samir, was it important?
No, I just want to say what Erik said.
Good. Okay. So this is how it could look like if one of the tests fails. So there's the category is sportsy for some reason instead of sports. So yeah.
Sportsy, frenzy, just so you know. It might be related.
Next
Now,
one.
If we continue, this is, I think, still for most people very intuitive, although we've had quite some feedback like, we've never thought about actually putting these things in a sequence, in a storyline somehow. People do all these things, go from one to the other and again and back and this and that. Our next most natural step, and the last step we really agreed on, was
really.
going into conditionals. We agreed on kind of,
Yeah.
was going into conditionals. Because if we look back at the Mount Doom example, there's a lot of unnecessary or definitely not usable, from a design perspective, code in there. So what we can do is a few very simple refactory patterns, like explaining variable. Again, documenting what you learn about the code is one option that you have. Again, think about the feedback loop, the fact that you don't want to learn what this thing means every single time. There's a role divided by 2. It's not equal to 0. Yes, we all know what this means, but do we really need to figure it out? We already have enough things going into our brain that we need to take care of. Do we really need to, every single time, even that 1 second, to think, oh yeah, it's odd. All right. So what if we start documenting that very simply in an explaining variable, for instance? One of my favorite things to do is, again, play with Lego. And again, go like, okay, there are 2 kinds of logic in here. And typically in any conditional statement. You have, what? Okay, sorry. You have what I would call coordination logic, the conditionals, and you have real action logic. What should happen in this scenario? Split these. It will make your life a lot easier. Whether you do it, whether then you create interaction tests around it to make sure the coordination works and then use action tests to actually test the action itself, that's up to you. But if you decompose these conditionals into smaller bits again, it's easier because typically when you want to change something or you want to look for something that is wrong, it is in either of these 2. Almost no single, I've had it only happen twice in my career that we needed to fix something in both at the same time. It's either your conditional logic, either your coordination logic that is off, or it's the activity that should happen in this situation. So what if we split them out? Again, creating focus on one of these that we don't have to. Because this is all noise that is going on. What if we can avoid part of that noise and just go like, okay, are we talking about the coordination?
Sorry.
No, it's good. Or are we talking about the actual action logic? So these are definitely 2 of my more revealing intent because I love maximizing clarity in code. But decomposing this, extracting methods out of this, will make life a little bit easier. So this would mean in the code, ...
Okay, So this is the original method, and then we just created some explaining variables, and we created some methods that explain a bit more what they were doing. And it still looks like a mess, and it's still not finished. But then, again, if you want to change the behavior, you can go into the method where the behavior is described. And if you want to change the conditional, you can do that in this higher level workflow view. And what had to be done to do that was a lot of stuff. So I'm not going to go into all the details because we're running out of the time for that. But this is basically extracting behavior, making clear, putting the behavior in their own methods, and doing all those refactoring steps. This is not perfect, right? And I think the most interesting thing that happened when we prepared the talk was that we had different ideas about what the order of refactoring steps is, and what is the best order, and what is the most useful thing. And that's because we have different experiences, and that's because it's different for every situation. And unfortunately, there's no best way to do everything. You need to practice all the steps, and then figure out what the right one is. What I like to do at this point in the code base is figure out what is my domain. We have roles, we have players, we have the penalty box, we have positions, we have the board, we have categories, we have questions, we have move, we have gold coins. Okay, that's it. So we have all these concepts in there that we can use, if you were in Samir's talk, as types, where we can put all this behavior in. So let's make our domain visible. Let's put the behavior where it belongs with the data that is related to it. And that will lead to a better design. So let's go and get that out of the code. And I think this is really advanced, how to actually get to a good design. All those automatic refactorings in the IDE are only building blocks that lead you to better design. So if you want to know more about that, it's a journey. You have to learn it. But there's the refactoring.org site where you can read about all the different refactorings you can do. And it's just a matter of practicing, I guess.
So there's a lot of techniques, a lot of things that you can focus on. For some reason, and both Franzi and Koen asked me this at some point, I was reluctant to go into types already. I don't know. I have biases, apparently. I don't know why. And this is interesting because I want to discover this. So I'll be practicing this refactoring in the next few weeks. There's a lot of things you can do. Definitely encapsulate primitives. If you weren't in Samir's talk, watch it. Really. This will make a difference. Encapsulating collections. We used to do that back in the days, 10 years ago. You can even, when you extract methods that you feel you want to move to another class, why not make those pure functions? If you don't know what they are, we're not going to tell you. Ha. So Google this. Read about this. Most people that have only worked in object-oriented design environments, and they don't know about this, this can be a big thing. So you can use a lot of things, even with these pure functions. You can do like TDD as if you meant it, to actually build these from scratch again. So there's a lot of things you still do, and it also depends on your context. For instance, the inheritance, if you want to turn that into delegation, that's really cool, but with this kata, the trivia kata, it will not work because there is no inheritance.
I think one of the important parts is that you regularly run your tests, that you make sure that you stay in the green. You know, you can use your version control system to go back if you got red tests. And you know, test drive new features if you want to, or test drive new design parts and then plug them in, so you never are in a big red step where you just refactor, and you don't know if you ever reach the surface again.
And try things. You have what you will see on the GitHub, on Franzi's GitHub page. We actually have the code there, and
yes, this is the link.
yes, you can actually go through them. You can have a look. These are very, very small commits. Why? Because this is a learning exercise for us as well. So with small commits, you can turn back whenever you want. So if we look at this, it's about experiments, and nothing is set in stone, apart from Mount Doom itself, because it is a big rock. So, but apart from that, the journey towards that is just your choice. We believe that some of these techniques that we've shown you in sequence make sense in most cases. But again, it is your journey. It is your ring to bear, and to get to Mount Doom, hopefully, before losing any of your comrades, and maybe this time Sean Bean can stay alive. It would be nice.
Yeah, so thank you everyone for listening, and I know we didn't plan time for questions, but we answered some during the talk. We are still here, I'm still here until tomorrow, so you can always ask, and yeah, have fun, and I recommend Adi's talk on refactoring as well.
Thank you.